We provide predictive analytics mainly to car manufacturers, but manufacturers actually of all types of products, to help them understand from initial data how well their products are going to perform in the field at 12 months of ownership, all the way out to the end of life of the vehicle or the product.
So Deep View True Cost, it's a first time that we've been able to bring together millions and millions of service records and repair orders throughout the United States to really look for the first time what the true cost is, what's the actual spending on parts and components and labors as customers bring their vehicles in for service at a dealership or at a service facility across the U.S.
For more than a decade, WePredict has been working with manufacturers, captive finance companies, suppliers, fleet companies, and others to provide a unique view of their own field data. Combining our exclusive and validated forecasting methodology with warranty and customer pay service records across the industry allows a first-time view of competitive, predictive component performance. These insights save our clients millions of dollars on warranty, cut costly repairs, and galvanize their customer reputation. Our predictive insights reveal how each component and each vehicle will perform today, in 30 days, in 1 year, in 5 years, allowing our clients to become smarter businesses on many fronts, such as improved quality, increased dealership and after-sales opportunities, aligned appropriate accruals and cash flow, stabilized balance sheets with our insurance coverage, personalized with telematic data, and prioritize the service claims that most impact customer satisfaction. Accelerate towards certainty.
Good morning, everyone. Second day of Car MBS. I hope you had a great evening. We're able to get out and do some networking and maybe see a little bit of the city. I want to thank everybody who was involved in our panels yesterday. Thank all of our sponsors. We wouldn't be able to do this conference without all of the great participation that we get. Same as yesterday, I'm going to kick off today with another acronym, and this is not only am I going to talk about leadership, but also about social equity, as equity has become so very important, and so many of our companies are really taking a stance for equity and making things happen. So this acronym I didn't even know existed until I did a little bit of research, and it's called PANS. Who knows PANS? It's an acronym I didn't know existed, but probably your kids do. Pretty awesome new stuff, PANS. So there's an acronym for us, and this is all the things we've been talking about this week. So when we think about that in terms of leadership and social equity, P, I thought the first thing that came to mind was patience. Patience in the way people communicate, patience in the way they may approach a problem or think about how to manage people maybe differently than you do. But have patience and take time to listen to what they're saying. Secondly is action. I mentioned earlier, A is for action. I mentioned earlier that we have all made, as corporations, as businesses, statements about our stance on social equity. Now is also the time to take that action. So if you look at your succession planning and don't see a person of color or a gender diverse person in your pipeline, why not? What am I doing exclusive rather than being inclusive? Or how can I help do some training or get people prepared to be on that pipeline? What action can you take? N is non-judgmental. I think sometimes we look at certain people and immediately form an opinion. It's easy to do based on your previous references. Just erase those from your mind. Listen to the person. Let them show you what they're all about. Let them demonstrate it. Don't be judgy. And then lastly, S of PANS, is statusless. When you walk in the door in the morning, take your title and put it next to your chair and don't think about it for the rest of the day. I think the pandemic has taught us a lot. I know in my small office, whoever happens to be there last is now turning off the lights, no matter who used to do it, making sure the front door's locked, making sure the dishwasher's unloaded if you notice the dishes in it are clean, and or running it if you're the last person to leave that day. It doesn't matter who you are. Things that used to be done for you, it doesn't matter. You all need to work together and get the job done. And I really think this is the first step of being a servant leader, which is really, really essential to be the kind of authentic leadership that Jan was talking about last night, and I think that each of us strives to be. So PANS, pretty awesome new stuff. And we're gonna be talking about a lot of that today. So let's kick off day 2. So let's go ahead and have a seat, and I'll introduce our panelists. And what we're going to do is I'll introduce each one of them, and then they'll give a short 3 to 5 minute dialogue, and then we will move into Q&A. And same as yesterday, if you have questions, please submit them, and everything will be fine. So I'm going to start with David. David Knight is the founder and CEO of Turbine, the first distributed exchange for data encompassing the physical world, AKA the Internet of Things. Turbine, am I saying that right? Turbine? Thank you. Is focused on bridging 3 major sectors that increasingly need to share data, mobility, electricity, and infrastructure. The platform creates context, trust, and liquidity for the data being generated by these sectors at scale. David is a serial entrepreneur, educated in applied physics. And your expertise in core technology includes multispectral sensing and communications, digital auditing, messaging, enterprise software, and distributed systems. He's highly involved with building the global email industry and has architected solutions for consumer products, defense, entertainment, and factory automation. He's an original executive of the nonprofit Ansari X Prize that literally launched the private spaceflight industry. Knight continues to promote entrepreneurship and STEM education. He's a trustee of the California Science Center Foundation, which owns and preserves the Space Shuttle Endeavour. So we have a space person just like Bezos and Branson. So go ahead and provide your opening remarks and welcome.
Thank you. Thank you. So everybody hears that we have a space shuttle, and that's pretty much the only thing anybody wanted to talk about. So at the break, if you want to talk about the space shuttle, I'm way into it. So let me go to Clickerville here. So in short, Turbine is a relatively new company. We were started on the premise that if you look at the history of technology adoption, eventually you get to these big breakpoints where scale has to happen, and things scale or they don't. And we found that in the world of data, specifically Internet of Things data, and very specifically the data generated by objects that move, vehicles, we found that there were a lot of platforms showing up to process the data, capture the data, that sort of thing. But we knew that eventually we had to do what people like the commodities industry did. Instead of just the brokers, you eventually had to create, the Chicago Mercantile, the big exchange in the sky that all the brokerages went through to get to each other. And the real goal is to eliminate the idea that you have to have manual contracts involving a lot of attorneys and discussions. Couldn't you just share data if you solved all of the various issues that are regulatory, business issues, conveyance of rights, who can control, who gets what, under what conditions and when, and most importantly, to have a high security, sort of a trust envelope around all of it so that everybody can watch what's happening when they need to and audit it. So now I'm gonna just show a quick 2-minute video that does a better job than I do of explaining what Turbine is.
The world is changing and data is now generated by everything around us. Sensors are being added to the machines, objects, and systems of our physical world, often called the Internet of Things. Sensor data is being produced at a rate that will eventually exceed what human beings have created since the Internet was started.
The amount of information is staggering, yet most businesses use it for only a moment and then discard it, or back it up into silos that are inaccessible to the bigger world. But there are huge opportunities in this data waiting to be discovered. Meet Turbine. Turbine is the first global marketplace for physical world data. Everything from the power output of solar farms to tracking drones and airplanes in the sky, sensor inputs of virtually any type at every altitude, even in space. Turbine is a true marketplace, gathering data from suppliers, curating it, and making it easily and rapidly searchable by machines, processes, and people. Its rules and filtering engine is designed specifically for turning physical world data into actionable information, taking into account factors such as ownership rights, legal, regulatory, regional, and competitive issues. It's not for storing people's personal information or pictures, just sensor data. Any organization can place data into the marketplace where it gets cleaned, graded, indexed, and then priced dynamically. Suppliers can be paid when their data is purchased. For buyers, Turbine does the heavy lifting of finding data sources and forming the trading relationships needed to reliably obtain the data. Buyers can bring the data directly into any end system, ranging from big data analyzers to moving vehicles. The applications are almost endless. Imagine a power utility having complete end-to-end visibility on every element across the grid, from home generation and storage to renewable energy providers. Imagine knowing what's happening with the soil throughout a farming region, or all the regions. Imagine a city street talking to self-piloted vehicles, giving them an enhanced understanding of the neighborhoods that they're traveling through. All of this is being enabled by Turbine. Prior waves of information experience have allowed us to take the pulse of humanity. Turbine will let us take the pulse of the Earth.
So if you want to talk more about it, see you at the break.
Yeah, or send us questions, right? We
Or
can
send
do
us
it live. So our second panelist today is Brett Scott, who's the VP of Partnerships at Wejo. Thank you. In this role, Brett uses more than 3 decades of knowledge in the automotive industry to bring partnerships between Wejo and OEMs to life. With technical and commercial experience from GM, VW, FCA, he's equally comfortable discussing trends in the mobility sector as he is uncovering the mutual benefits of working together on a project. Born and raised in Pontiac, Michigan, I was born and raised very near there too. Brett is the product of several generations of car enthusiasts and can often be found under one of his classic cars. His knowledge of municipal operation has come from his service as city commissioner in Pleasant Ridge, Michigan, where he now lives. He holds a BS in electrical engineering and an MBA specializing in globalization from Lawrence Tech University. Brett.
Thank you. Thanks everyone for coming today. You know, it's an interesting moment in time we're all living through in the auto industry and in the transportation industry as a whole. We're in a bit of a quandary, really. On one hand, the transportation industry has been built on choice. For most Americans, for many years, it was the second or third most expensive purchase we make over our lifetime, somewhere around housing and education. So there's an incredible amount of money associated in the choices that we make around transportation, and it's clearly about more than just moving. We choose our seating, the environment, we choose where we're going, and there's a lot of interest in understanding why we're making those choices and why there's so much money invested in what amounts to about 50 minutes a day that we spend behind the wheels of our cars or on our bikes or on public transportation. So that's at the start of why there's a lot of interest in the data that's coming from cars and from other sources to understand that. Now, the other side of the quandary is that for the first time in the transportation industry, we're being asked to make changes. We're being asked to think about the ecology and the health of the world. And so we're seeing most of this conference around battery electric vehicles, and in fact, I'd encourage everyone to think about zero emissions miles rather than battery electric vehicles. so that we think about how we get to just a more ecological state. And the data that we're generating from our cars today, the data that we're generating from other sources will help inform us about what we're doing today, how we're living, and where we're moving into the future. And that's really where a lot of the interest is coming from. Just understanding what we're doing, how we're behaving, how we're interacting with each other, and using that information to shape where we move in the next 15 to 20 years, because it is a very dramatic change. I joke with friends that General Motors got out of the electric car business in 1912 with the invention of the electric starter motor. And now we're seeing literally that same big change occur again back to electric, whether hydrogen or battery electric, because of a higher cause over and beyond our choices. And we're all going to get there. It's just going to require us to understand where we are today, what we're doing today, how our habits are shaping what we buy and where we spend our money, and then we'll build products that meet those needs. So I'll just spend a couple of minutes talking about Wejo. We're one of the experts, in fact, we'd say we are the experts in connected vehicle data. 11.2 million vehicles on our platform. We've got 58 million journeys per day that we're checking. We look at so many different kinds of sensors in cars that build over and beyond what you see from a mobile phone. And it's really critical that mobile phones are actually a great source of information, but cars are more accurate, and we can learn more about the environment, about people's behavior from the sensors in cars. The accuracy is great from connected vehicles. We capture data every 1 to 3 seconds from vehicles, so the feedback that you get from our data is very fast. And then we send out either the raw data or we derive output from it. And this is really important because a lot of folks don't know how to manage data, so we do that work for them. The accuracy is great, so we can measure down to lane accuracy or vehicle accuracy, whereas mobile phones are, in certain conditions, up to 20 meters. Road sensors are 100 meters. We see the data, we can send it out very fast for people. We can learn about the vehicle and the environment, so we understand temperature, weather, rain, light conditions that a mobile phone couldn't provide you. And just as an example, I have a slide here that shows our view of LA. We have practically every road in LA mapped, and we see it every 1 to 3 seconds. So it provides a way for people to really understand what's happening at the moment. We can typically find hot spots where accidents are likely to occur because of typical behavior, so we can do that historical analysis and do some predictions on what's happening on roads. And because EVs are such a big topic, we have about 120,000 EVs on our platform right now, and we can provide good analysis on what's happening with electric vehicles, how people are charging, where they're not charging. An interesting statistic, the average gas car is driven about 36 miles a day. The average EV is driven about 16 miles a day. So people are training themselves how to drive less, even during the pandemic. When we talk about 500-mile range, the average person is driving 16 miles. So there's a conversation to be had about how to get the most value out of cars and the move to electricity or electric vehicles. And I'm at 0 seconds, so I'll stop there. Thank you
so much. Our third panelist is Chad Chesney, who's the Vice President and General Manager of the Transportation Business for National Instruments. In this role, he's responsible for driving business growth and defining the products, services, and capabilities required to meet the unique needs of National Instruments customers in the transportation space. He joined the company in 1994, and has held various leadership roles in sales, marketing, and applications engineering in both the United States and Asia. He most recently served as Vice President of Product Marketing for National Instruments Data Acquisition and Control Products. He holds a bachelor's degree in electrical engineering from Vanderbilt University, and he also represents National Instruments on the Vanderbilt University School of Engineering's Board of Visitors. Chad.
All right, good morning, and thank you, Carla. My name is Chad Chesney, and I am the Senior Vice President and General Manager of the Transportation Business Unit at NI, formerly National Instruments. And our purpose is to help our customers engineer ambitiously. And I think all of us at this conference can relate to that concept. Together, we have an inspiring, aspirational ambition to transform our industry. And there are major megatrends that we're all familiar with that are driving that. My team wakes up every morning thinking about how we can help you accelerate innovation, in particular in electrification and autonomy. And we're focused there because we know that these areas are moving super fast. We know that the number of vehicles that will be electrified and the number of vehicles that will have at least level 2 autonomy capabilities are ramping much faster than vehicle production on its own. And that puts us all in a tension between innovating quickly and ensuring that our innovations perform as expected when we release them to the market. Now, another trend underlying these mega trends is that more and more of the capabilities of our innovation are going to be defined by software. Swami mentioned this in his keynote yesterday morning, and that because the software iteration and development cycle is so much faster than traditional cycles, that exacerbates this tension between moving fast and ensuring that our products perform. And we know that from IHS that a significant amount of our R&D will be spent on software in the years to come. Now, that tension also creates an opportunity. So what NI does is historically focused on test. We help our customers to accelerate their product development workflow by reducing the cost of test and ensuring in these new spaces that we can affordably test the near and literally infinite number of scenarios that our innovations will be faced with in the real world. And with the advent and extreme acceleration of software and the data that it produces from math-based design to simulation to hardware-in-the-loop test into manufacturing and in-use data, we are creating a digital thread that connects each of the steps in the product workflow so that data collected in one step of the workflow can accelerate and be leveraged to improve other steps in the workflow. So you could imagine data from our simulations being used to do predictive maintenance for in-use. You could see data being collected from in-use capabilities to improve the models that are used earlier in the design process. And by leveraging this data in this way, this connection, we can connect historically siloed steps and accelerate our innovations. Now that's a big job, and our belief is that no one company can do it on their own. So NI is developing partnerships with Cadence, Ansys, the MathWorks, other industry leaders that have a role to play with data throughout this design cycle to make these connections seamless so that data can be shared. And the data then can be a foundation that we monetize, whether it's in our P&Ls through reduced costs or lowering warranty set-asides, or can be monetized at the revenue level by adding new types of value to our customers in the automotive industry. But ultimately, this data will be the foundation by which together we can create the future faster. So thank you, and I'm excited to join the panel this morning.
Thank you, Chad. Our fourth panelist is virtual. I think we'll see him on the screen. But let me introduce Nassar Modi. He's the head of W Worldwide Business Development at Amazon Web Services. And this is for connected vehicles, including mobility and autonomous driving. He has 12 plus years of connected vehicle experience, ranging from in-vehicle infotainment systems to cloud platform. Prior to Amazon Web Services, he led the automotive and consumer verticals at Gracenote, including a machine learning-based portfolio of products. Nassar has been an integral part of the automotive value chain and previously held several positions, including product management, sales and engineering at NVIDIA, Qualcomm, and Jasper. He has a master's in electrical engineering and business administration and lives in the San Francisco Bay Area. Nassar, to you for your opening comments, please.
Yeah, thank you very much, Carla, and really glad to be on this panel. Wanted to actually discuss and share some of our views on how we think about monetization more holistically. And I'm sure a lot of you are quite familiar with AWS as the leader in cloud space, but automotive has been a strategic industry for us for a number of years, and we serve our customers with a combination of technology and business leaders, both from the automotive industry as well as cloud expertise. In a lot of our conversations with our customers, what we realize is there are 5 different trends that is going to propel the next phase of innovation within connected and software-defined vehicles. I wanted to highlight a couple of them that are quite relevant to our discussion today. One, a lot of our customers have started to realize and implement their data strategies on cloud. And this would allow them to break the silos and get the most out of the value of the data that other panelists described. And second one is the utilization of ML to optimize the value of data that they have received in terms of creating the cost optimized solutions for themselves within the enterprise as well as for their own customers. As you can imagine, across the industry, many of our customers have gathered enormous amount of data across different data types. So you think from connected vehicle data to ADAS and AV data, supply chain data, and a lot more of that. And one of the common problems that industry is facing is how do we unlock the potential of data? And so there are some certain foundational things that we see our customers thinking about how to break the silos of the data. One of the big challenge is this data is all locked into different data silos, making it inaccessible to a lot of the developer community across the enterprise to really make use of that. And so for what we have seen is more and more customers are not only thinking about highly available and flexible while secure data storage, they're also thinking about how to use different tools for analytics and machine learning so that they can optimize the data that they have stored. They're also looking to exchange the data across different services and while wanted to have unified governance. That has triggered use of what we call it as a lakehouse approach. A lakehouse approach does not require you to load the data, any kind of data, but it provides a huge scale in terms of terabyte and exabyte scale of data at low cost, provides that unified governance and analytics, but also democratize ML with SQL. Another trend that I talked about was the AI/ML at the edge. And when you think about machine learning, you have to think really holistically and how it is related to data services and also offers not only the machine learning capabilities, but also big data processing capabilities, and also ability to deploy these machine learning inferences back to the vehicle. So now you can create that entire chain of value of the data that you're collecting across different data sets and culminate into machine learning experiences. How we work with our customers. If you want to build a data vision and strategy, we have a program called Data-Driven Everything. We collaborate with our customers deeply to bring that vision on how to build a data strategy. But if you have a strategy and you need help executing that, we offer AWS Data Lab that would help you create the tangible deliverables across your data strategies. So I'll pause with this last example with BMW Group. And BMW Group also started their journey thinking about their data strategy with AWS with one problem to solve, which is how do I make the most use of my data and how can I create machine learning insights based on my data. And they quickly realized that the data is actually locked across different silos within the enterprise. Even a large enterprise like BMW, they wanted to address that by breaking down these data silos, and they built something they call it as Cloud Data Hub. They were benefiting from the AWS in terms of having that integrated capabilities, not only from the data management services, but also the analytics and machine learning capabilities. If you're interested to learn about what BMW has done with AWS, please reach out to me. Or you can also find our reInvent session on YouTube to learn how BMW Group built their data strategy with AWS. Thank you, Carla. Back to you.
Thank you very much. So let's kick off our panel discussion. And if you would like to submit questions, I see some folks already have, please do that through the Q&A on your app. But I want to start with Brett, because I found your chart of Austin really compelling, especially considering the news that came out this morning. We're probably going to have an executive order signed today by President Biden to non-bindingly dictate 50% of EV sales by 2030. And as such, the charging infrastructure is really, really important. And when I talk to a lot of people, they're thinking, we just need to put them at certain spacings. But I think that's wrong based on the data. We need to be putting these stations where people are going to actually be using them and by where we think purchasing decisions are going to be made or where the greatest population is going to be. So based on what you have done in Austin, how can that lead us to the right conclusion? How can this data help us?
That's a great question. What we're seeing around the country is that the result or the answer isn't the same for every city. People have different driving behaviors in different cities, and Austin will have its own characteristic. Where we start, though, is looking at how people drive their cars today. I mean, we have habits around how we fill up today, how much time that we spend at a fueling station, whether we go there to do more than fueling. Maybe we get our gas at a large big box store and we do shopping and fueling. All of these things go into deciding, how and where we spend our time and how we fuel. And that's going to change with electric vehicles and with hybrid vehicles. And we see that in the data. I'd mentioned earlier that the average electric vehicle owner drives about 16 miles a day. Some of that is because people have gotten smarter in the way that they drive. But that's also allowed people to charge at home. I mean, with 16-mile range, you practically don't need level 2 charging to charge overnight. You could plug in, and that satisfies the need. But a lot of people aren't doing that. They're charging in other places, and we can tell from the data where they're stopping more frequently. And those locations are probably where the charging station should go. And that might not be a standalone location. It might be associated with something that they do throughout the rest of their day. The other challenge with charging stations is that as we go from level 2 to level 3 charging, the infrastructure required to support that station is rather expensive, and it's actually difficult to run the cables a far distance away from a building that might support that level of voltage anyway. So we can help people determine where the best places are to locate those charging stations based on what people do all day anyway.
Thanks. And if anybody else has a comment, just let me know. And Nassar, if you'd like to append at any moment, please just raise your hand or give me some indication.
I'll jump in there
Sure.
too. I think another interesting element of that is if we can use data to predict, like you said, where people are going, we may be able to influence performance in the car to precondition the battery at the right time and to prepare for the most efficient charging time while the consumer is at the location where they're stopping. And so that data can be used even to influence how the vehicle behaves in that ecosystem.
Will you also be able to, I'm thinking now of Gas Buddy and some of these other apps, will you also be able to help people with understanding the different pricing that might be available at different times of the day and help guide them to, where there's spaces available and maybe what time they should charge, things like that? Will we have that kind of data, thinking again about the monetization of this data and the providers of the electricity?
So I think we will. I know personally, one of the things I'd be super interested in is not pulling up to a charger and realizing there's a 20-minute wait to get to a charger. So if we have data about what's being used at different stations and how that's impacting our car and what we're trying to accomplish, and artificial intelligence can help predict that, I think we can add a lot of value to our consumers.
Yeah, and it's interesting because my spouse is one of these people that gets he has his route and he knows the stations and the price and he'll try to hit that one. That might save him a penny a gallon or something. But I can foresee people doing something similar with EVs, even though the expense is much less. Let me ask a question from the audience, and then I'll go back to my queued up ones. This is really quite compelling. My understanding is that an autonomous vehicle can create up to 2 terabytes of data per trip. Do we have the computing power today to process and analyze this today cost effectively and, more important, in a timely manner? Mainstream quantum computing, which was promised to be the solution, seems to be more than a decade away due to costs and issues with cooling. Who wants to tackle this one first? Nassar.
So answer is absolutely yes. We do have technologies today that would allow to our customers to offer pretty much unlimited computing. So if you think about, when you think about ADAS, AV, and variety of different data and simulation models that you want to run, there are two dimensions to that. One is the kind of instances that you would need would differ from CPU-based to GPU-based instances. And the second thing is our customers are also seeking the on-demand availability of this huge compute capacity when they need it. And at AWS, we offer both of that flexibility to our customers to achieve that. And I think absolutely there is a lot of technology and different compute instances that can serve not only L1, L2, but also what the future generations of L4 vehicles would require as well.
Absolutely.
So one technology you may be hearing about or even participating in is what they call mobile edge computing, or MEC. And AWS, for example, has a product called Wavelength, I believe, that is supporting this. So the idea is that using mathematical techniques that are going to get better and better thanks to machine learning, you place the processing problem where it needs to occur, and ideally with the lowest amount of latency from a cellular connectivity standpoint. And what's really interesting about it, when you're talking about terabytes coming from a vehicle, it's either going to be video camera raw data that you're going to not process on the car. But the one that is, just overwhelms everything is LiDAR, laser radar, incredible amounts of data coming from a LiDAR. I don't know why Elon Musk doesn't like LiDAR, but he's sometimes
changing his mind, they say.
He's changing his mind. So the interesting thing about mobile edge computing is now you can intelligently do the processing where it needs to occur. And if you still need that data to end up in the big mothership of the cloud, you can do that and backhauling it later when you have more data communications time available. So I think honestly, we're kind of still looking at this where there's a client and a server, but eventually the clients are going to talk to these intermediary mobile edge computing servers that will do a lot of the processing locally, and that'll really offload this grander data load that's coming at us.
Go ahead, Brett.
And then to add to that, we're learning that there are only certain pieces of that information that are important to the entire network. So you might want to know that a car experienced a pothole. You might want to know that you might want to feed the information that there's bad weather coming for other cars that are approaching the bad weather, or that you've seen an ice spot that caused the car to behave in a certain fashion. And so those nuggets of information can be handled on the 4G network today. They could be sent out and then shared with other cars of the network, far ahead of the entire processing of an autonomous vehicle going out through edge computing or other methods. So a lot of what we're seeing automakers do today is to compress that down into events, so that can be sent out in an easily digested fashion. So you don't have to send that entire stream of autonomous vehicle data. You can send those things that are just useful at this moment to other vehicles, or to help inform that own vehicle how to handle that spot when it sees it again.
So it's a matter of sorting and sifting at first to get rid of all the noise, so that it brings it down into a manageable amount of computational
Right. A lot of this will change when we get to 5G and the ability for vehicles to share information in other ways and share with the infrastructure. But at the moment, we're seeing that just shrink it down to the things that are useful to other vehicles, and then share it.
Another area where our data problem has moved from not having enough data to having so much data it's hard to deal with it is earlier in the design process for an ADAS or an autonomy system. The way that's done is you will send a car out to record real-world data. And just a couple of days of driving will produce petabytes of data, but it's in a remote location. You need to get it back into your server farms for testing so that you're playing it back to test your iterations on your design. So not only do we need more compute power, we need unlimited compute power, we also need unlimited bandwidth to move the data around the world to where it needs to be at each step in the process, whether it's early in design or when it's the cars being used on the road.
So, David, let me ask you a question. Talking about, really the monetization of data, and there are so many different applications that are feasible. So what kinds of applications will become viable and potentially lucrative as large volumes of vehicle-generated data become accessible to non-automotive third parties, if we can indeed make it accessible.
Right. So the latter thing, I'll go backwards. We put a lot of concentration, this is in Turbine, on how do you solve these conundrums of the silo mentality that goes way back before computing even, and the issues of, there's things like who can see my stuff under what conditions. There's regulatory compliance, which is increasingly, as we all know, showing up for data, starting in Europe. And then we've got these issues of, well, how do I monetize it? How do I do that at scale without a bunch of guys sitting around negotiating? You want to have it, in real time. So with all that being a problem space, the issue is, okay, well, who's going to pay for this data that is not in the automotive ecosystem? And if you look at things like, how we now have very commonly apps on our phones, that's not how things got started. You had to have that whole infrastructure before you could start putting apps on phones. And then the incremental cost of adding an app to a phone became almost nothing because the gigantic infrastructure from the supercomputer in your hand through the whole network to the cloud made it all very obvious. So to get to the core of your problem that you're stating, there are so many interesting applications coming at us, some are being talked about here at the conference, that are going to need staggering amounts of data that don't come from whoever is providing the application to an end user. So I'll give you a fun example. If you have LiDAR or radar or cameras doing machine vision on a vehicle, it can't help but kind of capture what's slightly above the plane of travel of the vehicle. No matter what you do, you could filter that data out. But what if somebody driving delivery drones down the street could use that data to know what's above the vehicles on the street? Like, tell me about the trees and the catenary wires for trams and construction cranes. That would be very, very useful to make a drone go more efficiently and more safely. I think the killer app, if you will, has to do with the display technology, which is augmented reality. So we already have sort of low-end augmented reality with these things you can play on your phone and things appear across the live video vision. There's going to be glasses coming. Early example would be the Microsoft HoloLens. And then you're going to have smart windshields are definitely coming. The big automotive glass makers, as many of you know, are working on safety glass that is a display. And so all of these are going to need data that is updated at the speed of moving the vehicle around or turning your head. So if you play first-person shooter video games, you know what I'm talking about. You have to really drive that rendered data very quickly to the display. And I think this will drive mobile edge computing, and it'll also provide brand new sources of revenue for data that the vehicles are generating naturally, and now you're going to have these extra ways to generate money from that.
Go ahead.
Yeah, I'd say there's no one killer app. There's no better time to reread Chris Anderson's Long Tail. It's really that story. There are lots of applications that are just waiting for the data pipe to become available and for the data to become consistent and reliable and accurate. And that's what we're seeing happen now. Almost every auto manufacturer is defining a way to make their data available reliably, consistently, and even more accurately than mobile phone data. Interestingly, someone a few weeks ago had suggested, wow, I'd really like to know which drive-through lane has the shortest number of people in it. I mean, that sounds like a silly application we wouldn't have even thought of 2 years ago, but if you live in a big city, you've seen cars queue for 30 minutes for a White Castle's hamburger. It just doesn't make any sense, but that's the world we live in right now. And imagine if we could help people not spend 30 minutes in a drive-through lane by providing data that says, go here instead of there to get to a faster meal. Mm-hmm. So those are things that are going to pop up and maybe die away, but these applications are becoming possible because the pipe is open, the data is available, and we can begin to build applications around them. And they will change over time.
Did you have a comment?
I agree with my fellow panelists that the number of applications that could be lucrative is infinite. We could make a long, long list. I'm sure somebody will figure out how to make money on advertising through the data, whether we like it or not. But another big impact is how we would use data for safety. So when you think about vehicle to infrastructure types of communication and sharing of data, if we could truly achieve the element of Vision Zero, that is zero accidents and zero fatalities, then we've had a massive lucrative impact just on humanity. Forget the economic part, but just the value for society will be tremendous.
And if you think about how cities just calculate, sorry.
It's okay. I'll go to Nassar next. Go ahead.
If you think about how cities gather data today, it's 2 rubber strips on a road, and there's a person that puts that rubber strip down, and there's a truck that carries that material, and that's really expensive. And there are 24,000 municipalities plus municipalities in the United States alone. So the ability to be able to provide that kind of information to a city could be a cost savings to a city. When we talk about monetizing, just to be able to grab the data from vehicles that are already riding down the road, to provide that information to decide where potholes are and where accidents might occur, and how to make bicycling safer in communities, and maybe where lanes get removed in order to handle multimodal transportation, which is going to become a big conversation around the country. All of these things are possible because the pipe is open.
Nassar, go ahead.
Just wanted to add to this discussion in the sense that as we think about building applications that can utilize data, one of the key aspects is to keep in mind the accessibility of data for the developers. And what we have seen is as developers get access to the data and the machine learning capabilities, there are a lot of different applications and services not only can be newly created, but also can be optimized what we have today. So we see increasing use of this integrated approach of not only having the data strategy, but also having that ML strategy to develop your entire application strategy around that.
So, when we talk about the data, I know we mentioned this earlier, the privacy issue. And the secondary issue, and maybe it's not an issue, is are we actually able to get the data that we need to be able to do this, to do the analytics? Some of you may know my background included the Columbus Smart City project, and we had a very hard time with the OEMs to be able to get their data. Even though we were going to get it anonymized, it was very difficult to get it. And conversely, we were hesitant to share it with the OEMs because we don't know the value of what we're trying to share. So my first question is, can it be shared? Under what terms? And then correspondingly, how do you assess the value of that data? Or can we assess the value? Who would like to tackle that one first?
I'll try to jump in. In my conversations with customers, I see a tension here also. On the one hand, I'll speak with OEMs and maybe a tier 1 supplier where there's a desire to share the data. Because if there's better data coming from how the components that are now part of the converged system is performing that could be shared from a vehicle manufacturer to the supplier of that component, it'll improve the design of that component. So there's a really practical benefit of sharing. But as you said, there's a traditional mindset that data needs to be protected and not shared. So I think we're going to have to kind of embrace a growth mindset there and figure out the terms by which it could be shared. And I think each company will have their own view of that. But if we don't share it, we're going to miss out on a big opportunity to improve the innovations that we're trying to create.
Nassar, you had something to add.
Yes, just quickly to add there, this is really interesting idea of sharing the data across the value chain for quality. And we have served a lot of our customers who are seeking to share the data across the supply chain to triage the quality problems on the field. And one of the big piece of that is the speed at which you can resolve the problem. A lot of the challenges have been around how do you share the data securely and how can you govern that? And there are a lot of different architectures now in place that would allow the value chain players to share the data securely, but only share the data that is required for a particular problem. So there are definitely technologies out there. I talked about data lake and lakehouse approach that would allow customers to do that. Back to you, Cal.
Thank you. Any other comment on that question?
Sure.
Go ahead.
Well, it's kind of what we're doing. So the first thing, a lot of these issues everybody's talking about, we at Turbine, we call it the whack-a-mole problem. We're just constantly, the city wants to do this, and the OEM wants to do this, and the power utility wants to do this, and the air quality management district wants to do this. So we're just totally, how do you make them happy? How do you make them happy? Hopefully informing design so that that works for the next N number of entities. The interesting thing is that, so we've done a lot of work on how do you monetize this data. Nobody has done it at scale, nobody. And so we've been talking to all the big analyst firms. These are like the McKinseys, not the companies that do data analytics. And we've learned that there's a lot of variables that have to be resolved. So we looked at how they do this in things like the Chicago Mercantile, literally. How do you price a commodity? We're not at the place where this data has been vended enough that you can just have a sort of an auction. And I know you guys will smile when I say this, but the average data consumer, and this would be a company as a consumer of data, they think it should be free, and the people generating the data think it should be infinity. So you're never going to have an auction at the current environment. So we realized that the exchange has to set the price, which is how it works in commodities trading. I think we're going to go through some bumpy years while this all gets kind of worked out, but gravity tends to work, and eventually people will realize that you can safely, securely, and in a controlled manner let that data go across the transom to a third party that has nothing to do with your industry in the name of things like public safety, security, and of good old greed. That how do I monetize data that I'm already paying to generate? Wouldn't that be cool if I could make money from it? It's found money. And this has come true if you think about the fact that we all, for better or for worse, just give all our data away to Apple and Facebook and so on. I won't say Amazon. But we run on AWS, so we're very in there. But the really important thing is that we do tend to give that away in exchange for quite a lot of privacy. That has got to get dialed in. There's going to be regulatory things that show up like they are in Europe. But when you're talking about the data generated by machines, as long as you're really smart about how you filter that data, you can avoid the personal identifying information question pretty readily. We're not just talking about, because we're going into this era where you may not own your car. You may just be sharing a car. The car may just come to you when you need the car. So we're really, if you try to look not too far out into the future, a lot of the applications have to do with the cars are rolling sensor platforms that cover a lot of the landscape. It's sort of like having very low-flying satellites that are just kind of painting the landscape. And, so a whole bunch of companies and smart people at universities and are working on how do you break those barriers down in a way that everybody's happy with. And then now you have the platform for everything to really go fast, like it did with app stores on phones.
So let me ask about data and data privacy, and let me tell a little story first, and maybe you can help me understand how we can do better. I love Reese's Peanut Butter Cups, confession. And I buy them on a pretty frequent basis. So now, suddenly, and I don't know if it's because I shop, I use my app at the store and do shop and scan or what it is. Now, anytime I go by certain exits on the freeway, I get this Reese's symbol that pops up. And it's like, what? Why is a Reese's symbol there, right? But it's very not helpful for me because I buy them in large quantities. I don't buy just 2 at a time. And I only like the dark chocolate or the white chocolate ones, okay? So it's really not helpful. So somebody's giving my data away and telling me unhelpful stuff. So and I don't want everybody to know I like Reese's. People in my car, I don't want to see these Reese's signs popping up. It's my my bad habit. So anyway, how can we do a better job of this? How can we, really keep data secure? And that's a minor thing from a privacy standpoint, but privacy is a big issue. And Europe is starting, what do we foresee coming in this country? And how can we avoid this darn backlash, that I'm sensing here with my Reese's fetish? So who wants to tackle that?
Sure, I'll say, and those of you in the audience will appreciate, short of sending David Bowie into space on a rocket ship, there is nothing more regulated than a car. It is the most highly regulated commercial item that you can buy. It's It is your iPhone, your living room, your air conditioning, and roads that you drive on, and it's all highly regulated. And this notion of privacy is one of these pieces of its high regulation. And the auto manufacturers themselves have taken this incredibly seriously, so that the consent gathered from the consumer definitely guides what information is available to any of us. And they're taking it even a step further just to be absolutely certain that customers are aware that their data is being used for certain purposes, and people have the option to opt out or in. And really it all goes down to making sure that there's some value shown to consumers, that their data is being used for good, and that's what we're all striving to do.
So you have to go find this on YouTube. Somebody got William Shatner to read the iPhone user agreement. Just trust me, it's hilarious. And the user shall not sell the data. It's awesome. So why that's funny is that if you were to print out the iPhone user agreement, it's something like a 10-point type on normal spacing, 63 pages. So nobody reads it. Nobody reads the Facebook agreement, the Twitter agreement, the Google agreement.
Right.
And so you've given away, we've all given away those rights pretty handily in exchange for all those things being quote unquote free. But nothing's free, just like the drinks at the casino, nothing's free. So you are paying for that by giving those data rights away. In a car, you have a lot more control over it because it's this physical object that's shared by multiple users. And the control point is in the computers in the car and whatever agreements associate with that. But I think over time there will be a backlash. Europeans, as you all know, created the GDPR, which probably is a little more overbearing than it needs to be, but it's kind of a reaction to Google and Facebook, et cetera. I think the car itself, again, it's going to probably become more of a platform that people use for different applications. It's also a platform we're going to use ad hoc, as we're all learning from things like Uber and Lyft, where we don't own the vehicle that's moving us around anymore. So when you think about that, the privacy really comes down to, you know, what do you know about me? Well, they know all about your peanut butter cup thing, because something you're saying out loud is getting captured by Siri or Google or what have you. So you're really doomed. You're going to get lots of peanut butter cups mailed to you now, especially now. So anyway, I think we really need to worry about privacy in general, more from bad actors, not advertising, like, oh, I know where they are. And as long as that can be controlled, there are these overwhelming benefits to having that data available. And people will pay, and I know we're running out of time, but I will say that one of the biggest applications for the data coming from vehicles right now is to train other vehicles. So very quickly, machine learning, in the name, it tells you what's going on. The computer that is running machine learning software is learning. We're not at Commander Data or R2D2 yet, so it just doesn't learn on its own. So you're going to have, you have to have what they call training data. And that's what gets fed into the algorithms, and then they learn from it, just like the way a baby learns or something like that. So with that being said, there's a big market that's building very rapidly for the data that's coming from testing all the way through vehicles on the roads. And it's not about your personal information at all. It's about, I just need to know what these vehicles are doing and what they're being subjected to as they move through an environment. Very helpful to all these companies working on autonomous vehicles right now.
So let me conclude with a question. I know we have a lot more questions that I didn't get to, but I'm going to start with Chad on this one. If we think, today there are some vehicles that you can use to buy your gas or whatever. It's very limited right now in scope and only on certain models. Let's think maybe 5 years, probably at the rapidity that this is going on. Is it going to be a similar model in the future where you have to go to a place and pay, or is it going to be, or are we going to even be smarter with machine learning, where it's going to say, you know what, I know Carla on Thursdays always goes to Panera for their special soup that day. You know, is the car going to just tell me, hey, it's Thursday, I've already ordered it, just go get it, and it's already paid for? What do you think is going to happen in 5 years?
Well, there's definitely always been a trend toward automation. And so tasks that we did manually become things that are done automated and even automatically, so that we don't even think about them anymore. So I think the challenge for the automotive industry is that the cell phone industry has set such a high expectation for how that works. and whether the car will use the cell phone or the car will be the sensing supercomputer that happens to also be a car and do that automation for us, and how consumers pay for that will be the challenge. But I definitely think that manual tasks like getting out and paying at the pump, those will all go away in the favor of automation over time.
Brett?
And where the car helps that discussion is the accuracy of the location, among other things. So the car will know whether it's rainy or sunny, and whether you're at pump 4 or pump 5 or pump 6 at the gas station, or whether you're at window 1 or window 2 at Wendy's. Or, those are the kinds of details that the car can add to the purchase on top of the app that you might already have on your phone. And they're not in competition with each other. They're very complementary. And that's, I think, one of the bigger messages is that there's room and need for both in order for those transactions to work.
And David, in answering this, how can that information be monetized? What's the win-win for everybody?
Yeah, so we've identified, this will scare you, 21 variables that have to be resolved to price any type of Internet of Things data. It doesn't really matter whether it's coming from something in motion or not, even though that is one of the variables. We really just find that you have to look at the use cases, but doing that with machine learning is a whole new animal. And you have to look at things like geographic density and whether we're talking about aggregated data from a lot of vehicles or just from one and all those things. But the good news is there's a whole plethora of things like people working on autonomous vehicles. They're definitely willing to pay for the data if they can get their hands on it. And maybe there's a good AWS perspective on that too.
Yeah, I'm going to let Nassar close up the session.
Yeah, thank you, David, and thank you, Carla. Absolutely, I think there are a lot of different ways to monetize the data, I would say, and utilize the data. I believe that data analytics and machine learning capabilities are an integral part of any data monetization service, and making sure that we all get the right data insights. David, you talked about distributed architecture, and that is where we see industry heading, which is you not only want to think about data in silos inside the vehicle or in the cloud, but you have to have that distributed architecture that allows everybody to monetize data in the right ways without spending a lot of money in managing the data and getting the insights.
Well, thank you, panelists, very much. I know there were a lot more questions, so hopefully the audience can catch up with you afterwards and ask more questions, but I learned a ton and appreciate your time. And thanks for everyone who joined us in this session.